Prove that the parallelogram circumscribing a circle is a rhombus. Solution. Given A, B, C, D is a parallelogram circumscribed the circle with center O. That is, AD is equal to BC, AB is equal to CD. Let P, Q, R and S be the points where the circle touches the sides AB, BC, CA and DA of parallelogram ABCD respectively. Required to prove ABCD is a rhombus. Proof. Tangents drawn from an external point to a circle are equal in length. That is, AS is equal to AP, BQ is equal to BP, CQ is equal to CR, DS is equal to DR. Adding above equations, AS plus BQ plus CQ plus DS is equal to AP plus BP plus CR plus DR. Rearranging these, we get AS plus DS plus BQ plus CQ is equal to AP plus BP plus CR plus DR. This implies AD plus BC is equal to AB plus DC. Since AD is equal to BC and AB is equal to CD, 2AD is equal to 2AB, which implies AD is equal to AB. Parallelogram in which any two adjacent sides are equal is called rhombus. Therefore, ABCD is a rhombus.